The planets and the moons in our solar system are hiding secrets that could change our knowledge of Earth itself. Uranus stores heat we didn't expect. Mercury has been shrinking and cracking for billions of years. Jupiter's moon, Io, emits giant columns of volcanic plumes. These cosmic mysteries hint at forces and processes that could, one day, ripple through the solar system and even affect life here on our own planet. Back in 1986, Voyager 2 flew by Uranus and confused everybody. The readings showed the planet wasn't giving off any extra heat. This made it look totally different from the other giant planets in the solar system. That was strange because Jupiter, Saturn, and Neptune all release way more heat than they take in from the Sun. Fast forward a few decades, and two independent research teams went back through a mountain of observations. What they found changes the story. Uranus does give off more heat than it receives. About 12.5% more to be exact. The two studies show that Uranus is still slowly releasing leftover heat from its early days. That detail matters greatly because it helps scientists piece together the planet's origins and how it's changed over time. As for Voyager 2's odd readings, they now make more sense too. The flyby happened when the Sun was unusually active, which made Uranus act weird. So those early numbers likely didn't reflect its normal state. Even so, Uranus still stands out. Jupiter pushes out 113% more heat. Saturn gives off 139% more, and Neptune tops them all at 162%. And since Neptune is farther away from the Sun, distance isn't the reason Uranus is cooler. Something unique is happening deep inside. Maybe the planet's structure is different, or maybe its past somehow shaped it in another way. Another weird space body in our solar system is Jupiter's moon Io. Oh, by the way, did you know that Io has a brother moon named EIE? So, through a telescope looking at Jupiter, you can sometimes see them. EIE, Io. Right next to Old MacDonald. Hey, I thought it was funny. Anyway, back in 1979, Voyager 1 zipped past Io and saw something jaw-dropping. Giant volcanic plumes were blasting straight into space. It was the first time humans had ever seen active volcanism beyond Earth. Io looked wild, and ever since then, scientists have been trying to figure out what makes this little moon so ridiculously volcanic. For decades, one leading idea was that Io hid a global magma ocean just under its crust. That would explain why volcanoes are scattered pretty evenly all over the surface, as if they're feeding off the same underground reservoir of molten rock. NASA's Galileo spacecraft even seemed to back this up in the 1990s and early 2000s. Its magnetometer picked up a weird magnetic signal that looked like it came from a huge electrically conductive layer, basically liquid rock. By 2011, the consensus was that Io was sitting on a magma ocean several dozen miles thick. But now, that theory has been flipped on its head. NASA's Juno spacecraft has been looping around Jupiter since 2016, and in late 2023 and early 2024, it made a couple of super-close flybys of Io. The main goal was to figure out what was going on inside. Juno carries a super-precise radio transponder that scientists use like a stethoscope. Io's gravity field tugs on the spacecraft ever so slightly, changing the radio signal. By mapping those tiny shifts, the team can see how mass is distributed inside Io. The verdict is, there's no shallow magma ocean sloshing under the crust. Otherwise, Juno would have picked up way more distortion in Io's gravity field as Jupiter's tidal pull flexed the moon. But the data showed nothing of the sort. This leaves planetary scientists with a big puzzle. If there's no magma ocean, what's powering the most volcanically active body in the solar system? Io's volcanism is likely driven by tidal heating, because Io's orbit is a little stretched out by the gravitational tugs of neighboring moons. Jupiter constantly squeezes and releases this little world. The crust can rise and fall by as much as 330 feet, and all that flexing creates frictional heat inside the moon. Tidal heating does make magma, but if it's not pulling into a giant ocean, maybe it's stored in smaller scattered reservoirs within the crust. On Earth, different magma chambers feed different styles of volcanoes. But since Io doesn't have plate tectonics, it probably doesn't have the same variety. The new results don't totally rule out a deep magma ocean buried way below the crust. But if that exists, it would be so dense and iron-rich that it wouldn't rise easily to the surface. At that point, it's hard to tell whether we'd even call it a magma ocean or just a molten core. Now, at the same time, Jupiter's moon Europa, for example, is also tidally heated. But in its case, the heat likely sustains a salty liquid water ocean beneath an icy shell. Saturn's moon Enceladus is another great case. The Cassini spacecraft not only found signs of a hidden ocean, but even flew through plumes of water erupting from its south pole. So why does tidal heating make water oceans on some moons, but not magma oceans on Io? The thing is, magma is lighter than solid rock, so it wants to rise and erupt quickly instead of sticking around in one giant pool. Water, on the other hand, is heavier than ice, so it sinks and collects into a stable ocean beneath the crust. That's why magma oceans are so hard to sustain, while water oceans are relatively easy. In any case, even though tidal heating may not be great at making magma oceans, it's excellent at making water oceans. And since water is the key ingredient for life, moons across the solar system, Europa, Enceladus, and maybe others too, could be hiding habitable environments beneath their icy crusts. Io might be a volcanic inferno, but it's helping scientists figure out where else we might actually find life in our solar system. Now, let's move closer to Earth and explore Mercury. Believe it or not, this planet and our favorite pastries have something in common. They both shrink as they cool. Mercury formed about 4.5 billion years ago, and ever since then, it's been slowly losing heat. As the planet cools, its rocky shell contracts, just like a cheesecake or cookie that cracks when it comes out of the oven. Mercury develops fractures in its crust. These show up as thrust faults, giant cracks that push up sections of the planet's surface to make room for its shrinking interior. By looking at how those faults have lifted up Mercury's terrain, scientists can figure out how much the planet has shrunk over time. But earlier estimates were all over the place, ranging anywhere from less than a mile to more than 4 miles of lost radius. That's a pretty big range. So figuring out a more precise number has been a long-standing puzzle. To tackle the problem, researchers tried a new way of measuring Mercury's shrinkage. The old method used the length and height of uplifted landforms, but the results shifted depending on how many faults you counted in the dataset. More faults, one answer. Fewer faults, a different answer. That inconsistency made things messy. The new method avoids that issue. Instead of relying on every single fault, it focuses on the biggest one in the set. It's like finding the biggest crack in a cookie and using it as a baseline to estimate how much the whole thing cooled and contracted. Now, to test this, the researchers ran their method on 3 separate datasets. One had 5,900 faults, another had 650 faults, and the last one had just 100. And no matter which dataset they used, the results stayed consistent. Mercury has likely shrunk by about 1.2 to 2.1 miles due to faulting alone. But the planet didn't just get smaller because of its cracks. Scientists added shrinkage from other cooling processes to their fault-based results and found that the planet has gotten up to 3.5 miles smaller since it first formed. These new numbers don't just show how much Mercury shrank, they also give clues about its thermal history. They tell us how fast it cooled, how its interior changed over time, and how its crust reacted to that cooling. And this method isn't just for Mercury either. Researchers think it could also be used to study tectonics on other planets, like Mars, which has faults on its surface too. Now picture a strange world where molten metal falls from the sky. A planet where it rains glass, sideways. A place where the winds are many times the speed of sound. Even though these planets sound like stuff from a nightmare, they do exist. Would you survive on any of them? Nope. But come on, let's see why. Now, brace yourself, and I mean it literally, because WASP 127b is terrifyingly windy. On Earth, our most powerful storms produce winds around 200 miles per hour. And even Neptune, the windiest planet in our solar system, tops out at about 1,100 miles per hour. But on 127b, winds dash across the equator at a staggering 20,500 miles per hour. That's 35 times faster than a jet and faster than the speed needed to orbit the Earth. 127b orbits a star similar to our Sun, but it's super close to its parent star, only 4.3 million miles away. That's why it takes just 4.2 days to make a full orbit. The heat there is insane. Cloud tops reach 1800 degrees Fahrenheit, which is enough to melt almost, anything. And 127b is supermassive. Well, kind of. It's a gas giant with a diameter 1.3 times that of Jupiter, but only 1/6 of Jupiter's mass, which makes it a giant, hot, puffy balloon floating in space. The planet's atmosphere is so expanded that it's basically a boiling, raging storm globe, completely unlivable. If you somehow ended up on 127b, survival would be, impossible. The winds would toss you around, the extreme heat would cook you, and the planet itself would offer no solid ground to stand on. You wouldn't be able to breathe, move, or survive even for a second in these extreme conditions. But shockingly, that's not the worst planet you could land on. Imagine a world where it literally rains iron. This is WASP-76b, a planet so close to its star that the day side scorches at over 4,300 degrees Fahrenheit, hot enough to vaporize metals into gas. The night side is cooler, but still a blistering 2,500 degrees. Such a temperature makes those metals condense into clouds and rain down, like molten malted milk balls falling from the sky. The planet orbits its star every 43 hours, and it's tidally locked, which means that one of its sides always faces the star. The winds on the planet are absolutely insane. Blowing up to 11,200 miles per hour, they zoom across the planet, fueled by the extreme temperature difference between day and night. And 76b is huge. It's a gas giant twice the size of Jupiter. It's practically sitting on the edge of its star's outer atmosphere. Scientists say we don't fully understand the physics here. Eventually, this planet could spiral into its star, or radiation could strip away its atmosphere, leaving only a scorching rocky core. Now, a human on 76b wouldn't last a fraction of a second. The day side would instantly vaporize you, just like the night side. And don't forget about the winds. You'd be ripped apart before you even touch the ground. And iron rain would slam down around you like fiery pellets. Sounds like a place to avoid. Now, if you're looking for long-term real estate investments, avoid WASP-12b. This planet is over 1,300 light-years away in the Auriga constellation. It orbits its Sun-like star extremely closely, completing one orbit in just over one Earth day, about 26 hours. The planet's surface temperature reaches nearly 4,600 degrees Fahrenheit. It is 40% more massive than Jupiter, but powerful tidal forces stretch it into a football shape. But the main problem is that the atmosphere of this planet has expanded to nearly 3 times Jupiter's radius and is being pulled onto the star. And that means the planet is slowly being destroyed. Astronomers think that in about 3 to 10 million years, the planet could be gone for good. They found a huge cloud of stuff flying off the planet, including chemicals never seen on other planets before. No one would survive on 12b. The surface temperature is hotter than molten lava or any furnace on Earth. Any protective suit would fail instantly. The atmosphere is being ripped away by the planet's star, so there's no breathable air, just superheated hydrogen and helium streaming away into space. Plus, the gravity is extreme, so moving there would be, impossible. In any case, you would be vaporized almost instantly before trying to take a step. But however bad this planet sounds, the next world on our list beats it, because it rains glass on this planet. HD 189733b, I'll just nickname it Bubba, is a truly terrifying place, just 64.5 light-years from Earth. It's a gas giant, slightly bigger than Jupiter, and about 11% wider. But don't let that fool you. This world is a nightmare. Winds roar across the planet at up to 5,400 miles per hour, which is about 7 times the speed of sound. Temperatures soar between 1,600 and 2,200 degrees Fahrenheit, hot enough to melt metal. The planet also spins incredibly fast, completing one orbit in just 2.2 days. It races around its star at roughly 341,000 miles per hour. Its cobalt blue color comes not from water, but from a scorching, hazy atmosphere filled with silicate clouds. These clouds can condense into glass, and the planet's hurricane-force winds likely fling it sideways, making the rain fatal. Bubba is a hot Jupiter, a huge gaseous planet racing in a tight orbit around its star. It's also one of the most extreme, hostile worlds astronomers have ever found. If you somehow ended up in this world, survival would be out of the question. The heat alone is lethal. Insane winds would slam you around. An umbrella wouldn't save you from glass raining sideways, which would shred you in seconds. In short, you wouldn't last a heartbeat in this inhospitable world. But there's a planet that makes almost every other world look tame. It's Gliese 436b. It's small for an exoplanet, roughly the size and mass of Neptune, but don't let that fool you. Its proximity to its star turns it into one of the most extreme planets we know. 436b orbits a red dwarf star just 2.5 million miles away. To put that into perspective, Mercury, the closest planet to our Sun, is nearly 36 million miles out. This means that 436b races around its star every 2 days and 15.5 hours. That's lightning fast. A year there is shorter than a long weekend on Earth. The surface temperature is a balming 820 degrees Fahrenheit, which doesn't sound too bad in comparison. But there's the twist. The planet is covered with ice. Now, that's not ordinary ice, though. This is Ice 7, a dense, crystalline form of water created under unimaginable pressure. Imagine water so tightly packed that instead of melting under extreme heat, it remains solid. Scientists call it burning ice, and it's a form of ice that Earth laboratories can only replicate under controlled conditions. The atmosphere of the planet is just as bizarre. The planet is mostly hydrogen, like a gas giant, but it contains 7,000 times less methane than expected. Instead, astronomers find a surprising amount of carbon monoxide, which shouldn't survive in such heat. To make it even stranger, 436b is losing its atmosphere. The planet is wrapped in a huge cloud of hydrogen, probably pushed out by the strong gravity from being so close to its star. This cloud is 50 times bigger than the star itself. Unlike a comet's tail, it doesn't get blown away. It follows the planet. Astronomers think that 436b has already lost up to 10% of its atmosphere. Now, if a human, like you, somehow landed on Gliese 436b, survival would be impossible from the first second. The surface temperature is hot enough to vaporize skin and incinerate anything exposed. The gravity is crushing because the planet is dense and packed tightly with matter, which would make a person feel like trying to lift a car with every step. Even worse, can it get worse? Yes. The atmosphere is mostly hydrogen with high levels of carbon monoxide. Breathing would be instantly toxic, and a single inhale would shut down your lungs. And that burning ice is so solid under pressure that even if you somehow avoided the heat and toxic air, the ground itself would be a strange, brittle, crystalline surface that could fracture or collapse underfoot. Add to that the planet's rapid orbit. Completing a full year so fast means winds and atmospheric currents are extreme. No shelter, no suit, and no parachute could protect you. In short, you would be instantly boiled, crushed, and poisoned, all while the strange, dense ice underfoot refuses to melt. Well, bye-bye. So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, So the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around 2 red dwarf stars. These 2 stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found 2 Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. For what seems like ages, scientists have been hunting for another Earth, perhaps to find cosmic neighbors, or maybe just to have a backup planet for potential relocation in case we can't turn this one around. Now, thanks to the James Webb Space Telescope, they might finally have a strong candidate. It's called TRAPPIST-1e and is located 40 light-years away. 1e orbits a small star called TRAPPIST-1. It's an intriguing system that has 7 Earth-sized planets, all of which are nicknamed with letters from B to H. While 40 light-years won't be reachable anytime soon, that's still close. Well, in space terms at least. Our galaxy, the Milky Way, is about 100,000 light-years across. So compared to that, 40 is like a walk down the driveway. Or at least will be if our spaceships achieve a speed close to the speed of light, just like in the movies. Remember, a light-year isn't a measure for time. It's how far light can travel in 1 year, which is close to 6 trillion miles, which is a lot of zeros. So, multiply that by 40, and you get the location of TRAPPIST-1. So, bring a big lunch. T1 is a red dwarf, a type of star that's basically like a dimmer and smaller version of our Sun. It's only a bit bigger than Jupiter. Among this family, 1e sits in the star's sweet spot, the so-called Goldilocks zone. Not too hot, not too cold, at a distance where liquid water could exist on a planet's surface if it has the right atmosphere. Perfectly habitable, at least for creatures resembling Earth's residents. However, it's not just located at just the right distance, which is a huge plus. 1E also happens to be a rocky planet. Its size and mass are close to Earth's, which suggests it has a similar density and structure, as well as similar gravity, meaning no cool jumps like on the Moon. Now, Webb has picked up hints that there could be an atmosphere. The planet might be wrapped in gases like nitrogen, carbon dioxide, and methane. We have such a mix over here, too. Earth's air is built from the same elements. Atmosphere matters. Mars lost most of it, Venus has too much, and Earth got it just right. That's why we have cozy weather and oceans. If 1E really does have something similar, it could mean clouds, rain, and maybe even seas. The stuff that would make Earthlings feel at home. However, here is where it gets interesting. We mentioned that 1E is a red dwarf star, and that makes it dim, hundreds of times dimmer than the Sun. If you were standing on 1E, the star would look way bigger in the sky than our Sun does here. But it would glow red and dull. It would be like living under a never-ending sunset. You might think, sweet, it would be romantic, until it gets old. I mean cold. It has to be freezing, right? After all, how can such a faint star provide enough heat for life the way our Sun does? Well, funny enough, you won't need super winter-resistant jackets. The trick is distance. TRAPPIST-1e orbits extremely close to its star, just about 3% of Earth's distance from the Sun. If the planet were sitting where Earth is, it would be a ball of ice. But being so close also means that its year is only around 146 hours. That means it takes 6 Earth days for 1E to resolve around T1. Celebrating birthdays every 6 days sounds like a great deal, huh? That's a lot of cake. But wait, does that mean that each season would last about 36 hours? No, because the planet is almost certainly tidally locked. That means one side bakes in endless daylight and the other side is stuck in eternal night. Not exactly Earth 2.0. Without an atmosphere, you'd get a scorched wasteland on one side and an ice cube on the other. But with an atmosphere, the air can spread the heat around, smoothing things out. In theory, the comfiest spot might actually be the twilight strip between day and night, the so-called Terminator line. Again, a permanent sunrise or sunset. Instagrammers would love it. Red dwarfs are actually the most common stars in our galaxy, making up about 70% of all the stars we know about. And they live practically forever. Our Sun is projected to last 10 billion years. Red dwarfs could go on for trillions. It's more than enough time for life to develop. However, the short straw is that red dwarfs are kind of feisty. They erupt with powerful flares that blast out intense radiation. So, for planets orbiting so close, those flares can strip away atmospheres and sterilize the surface. It's like having a dream house with a beautiful view near a dynamite factory. Oops. That's what makes TRAPPIST-1e so exciting. If it does have an atmosphere, it would mean it somehow resisted billions of years of flare activity. And it might not be the only one. There could be plenty of exoplanets like this out there. Now, you may be wondering how scientists could possibly know what's going on with a small planet that's so far away. Well, they study light using a technique called transit spectroscopy. When TRAPPIST-1e passes in front of its star, the light filters through its edges, revealing clues about its air. Repeat enough times, and we start to see what it's really like. That's one of the most important features of the James Webb Telescope. It doesn't just snap pretty pictures. It dissects that light into thousands of slices, each revealing a different clue. It's also great when you remember that E1 is just one of 7 planets that orbit so close. So scientists have a lot to study in that part of the universe. Each transit gives them a little more data, and after enough passes, they can start to rule things out. No thick hydrogen blanket? Check. No Venus-style carbon dioxide swamp? Looking that way. What's left is a planet that might, just might, have something closer to Earth's atmosphere. In other words, nobody's sending probes to TRAPPIST-1e anytime soon. But with telescopes like Webb, we can already peek at its air from across the galaxy. If you follow space-related news, you are already aware that 1E isn't the first so-called Earth-like planet that reached headlines. Astronomers have been teasing us with candidates for years, and each one comes with a but, as in however, not your butt. For example, Kepler 186f. Back in 2014, it was the first Earth-sized planet spotted in the habitable zone of its star. People were really excited. NASA even made a sci-fi-style travel poster. The catch? Oh well, just one minor thing, the fact that it's about 500 light-years away. Even if we build a spaceship that could cruise at a tenth of light speed, which we can't, it would still be a 5,000-year-long trip. Then there's Proxima Centauri b. This one is close, just 4.2 light-years away, orbiting the nearest star to our Sun. On paper, it's a dream. However, its star is even moodier than T1. Proxima exhales massive radiation flares regularly, which makes everything unpredictable and unstable. And then we have K2-18b. The James Webb Telescope actually spotted methane and carbon dioxide in its atmosphere, gases which might hint at biological activity. Sounds great, except the planet is more like a mini Neptune, probably wrapped in thick gas layers and unlikely to have a solid surface to stand on. The bottom line? When compared to all these, TRAPPIST-1e looks like the most promising one. Close enough to study, rocky enough to stand on, and sitting in a sweet spot where liquid water could exist if conditions line up. Of course, we still need more data. 1e could turn out to be a barren rock. But the bigger story is that we're getting better at this. A few decades ago, we didn't know if other solar systems even existed. Now, we've found over 6,000 exoplanets, with more getting added almost every week. Odds are, plenty of them will be rocky, Earth-sized, and orbiting in the Goldilocks zone. Maybe we can't go there, but they could mean the discovery of extraterrestrial life. That's the exciting part. Every time Webb or the next generation of telescopes take a look, we inch closer to answering the big question: are we alone, or is the universe full of neighbors? Hey, get your dog off my lawn.
Take that giant space knife. Yes, you. It's time to visit the Sun and check what's inside. First, you're slicing through the corona, aka the Sun's wild hair. It's the Sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the Sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and boom! Instant heat wave. It's like the Sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully, or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit, hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're going to split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through?
Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. It's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system. I mean, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between IRIS and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide.
Some time ago, the James Webb Space Telescope spotted a super bizarre space object flying through our galaxy. First of all, it's not orbiting any star. It's a rogue object, just drifting through space on its own. Even better, this wandering thing apparently has a cake-like atmosphere, and examining it can be crucial in our future exoplanet research. Plus, it can help us understand how gas giants evolve over time, and what might happen to Jupiter in the future. You may object that Earth has a layered atmosphere too, with 5 major and several secondary layers. But on Earth, the air is mostly nitrogen and oxygen. As for other planets, they're different. Take Venus, for example, where the atmosphere is super thick and filled with sulfuric acid. There are exoplanets with water vapor clouds, or ones where the clouds are literally made of hot sand. But what about our rogue object? By the way, I have no clue why it got this reputation, but for some reason, scientists chose to call it SIMP. Ouch. Anyway, it seems to have its own unique combo, with cloud patches and weird chemical reactions happening high up. It is covered in clouds made of iron and magnesium, and its atmosphere has carbon-based chemicals floating around. Scientists have spotted auroras on it. Yep, like the northern lights we have on Earth, but way out in deep space. It's the very first time researchers have been able to do a sort of weather report on a rogue object like this. The next weirdness? The object doesn't really fit into any box. It's not a regular planet, because it doesn't orbit a star. But it's also smaller than a brown dwarf, which is something like a failed star. So it's something in between. Not quite a planet, not quite a star. And while it's not dangerous in the we're all doomed kind of way, scientists say rogue objects like this could actually mess things up pretty seriously if they wandered too close to a solar system. Their gravity might throw off the orbits of planets, which could lead to instability, or even space collisions. So yeah, while our rogue friend is not a threat right now, it might become one in the future. Now, this rogue object has some crazy stuff going on. First off, its day is only 2.4 hours long. Like, imagine the sun rising and setting in that time. That's real fast. It's also hanging out about 20 light-years away in the Carina Nebula, which isn't super far in space terms. Another thing that makes this guy special is the fact that it's the brightest free-floating object of its kind that we can see from the northern hemisphere. And since it's just drifting in space without a nearby star messing with our view, it's been directly photographed by telescopes, like NASA's Spitzer. That's actually super rare for stuff this faint and far. When scientists checked it out in infrared, aka heat vision, they noticed that the atmosphere of this rogue object was acting weird, like it kept changing, sometimes more heat, sometimes less. Something funky was going on, but what exactly? So, in July 2023, one team of scientists used the James Webb Space Telescope to dig deeper. They pointed it at SIMP and gathered a ton of data, around 6,000 measurements in just a few hours. First, they looked at shortwave radiation, which is kind of like high-energy heat, and then they did the same with longer waves a few hours later. They discovered that the brightness changed differently depending on the wavelength. Some parts of the atmosphere got brighter, some dimmer, and some didn't change at all. It was all over the place, but they noticed a pattern. All the changes fell into 3 groups. Each group had its own vibe, like its own little signature of what was going on in the atmosphere. And it turned out that the mysterious object wasn't just floating alone in space. It was super dynamic, with layers of clouds and gases doing their own thing. It could mean 3 different things were going on in the atmosphere. To figure out what exactly was behind all this, they built models of the rogue object's atmosphere. Apparently, the first group of curves likely came from low clouds made of iron. Yeah, iron, like actual metal clouds. The second group seemed to come from higher clouds made of this mineral called forsterite, which is basically a magnesium-rich crystal. And it looks like these cloud layers aren't smooth, they're patchy. That patchiness could explain why the light coming from them keeps changing so much. As for the third group of light patterns, they weren't coming from clouds at all. The light seemed to be coming from way above the clouds, from what they think are hotspots in the atmosphere. These hotspots are probably connected to radio auroras, kind of like Earth's northern lights, but happening in the radio part of the light spectrum instead of visible light. But even after all that modeling, there were still some mysteries left. Like, the first group of curves was all over the place, more than they expected. So they think it might be because of carbon-based gases like carbon monoxide floating around. They might absorb certain types of light at random times. In any case, this is the first time we've actually seen this kind of atmospheric chaos directly. But the few hours the researchers spent watching it weren't enough to fully figure it out. To really get the full picture, they'll need days of data, and they're hoping to use NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, to dive even deeper. Even though this mysterious object is not a rogue planet, they're definitely worth mentioning. These are basically planets that got kicked out of their home solar system. Yeah, like straight up evicted. When a planet forms, it's usually hanging out with a bunch of other planets around a star. But early on, things can get super chaotic. You know, planets crashing, shifting, getting too close to each other. And sometimes, one gets yeeted right out of the system. So, since they're not tied to a star, these rogue planets are just cruising through the galaxy, totally solo. If they happen to float near something massive, like a star or a black hole, that thing's gravity can tug at them. But otherwise, they just keep drifting. Most of them probably got booted when their system was still forming, and everything was a mess. But according to a NASA scientist, even mature systems can throw a planet out if the orbit gets too weird or something big knocks into them. Now, the next planet we gotta discuss isn't rogue. It has a parent star and all. But there's another cool thing about it. It's still a baby in the middle of forming, and it's pretty rare to catch in action. The baby is already about 3 times the size of Jupiter, the largest planet in the solar system. It's part of a system about 400 light-years away. It's been growing for about 5 million years, munching on gas and dust from the disk around its star, kinda like a cosmic buffet. But the thing is, when astronomers checked out the chemicals in the planet's atmosphere using a big telescope in Hawaii, things didn't add up. They were specifically looking at carbon monoxide and water, which can help figure out how much carbon and oxygen is floating around in that atmosphere. Turns out, the planet's chemical mix doesn't quite match the stuff in the disk it's forming from. That's a big deal because it goes against what scientists thought they knew about how planets are supposed to form. Basically, it's saying, hey, your fancy models might be a bit too simple. Planets are supposed to form by clumps of gas and dust crashing into each other and sticking together. Over time, they build up into full-blown planets. If that's true, then planets and their surrounding gas should have the same kind of stuff in them, chemically speaking. But PDS-70b is doing its own thing. So the scientists came up with 2 ideas to explain what was going on. It might be forming from solid stuff, like dust and ice, not just the gas in the disk. That solid material has carbon and oxygen trapped inside. So, by the time it melts and goes into the planet, it's already changed the chemistry. or the gas in the disk got more carbon after the planet already formed. Luckily, there's another planet in the same system, PDS 70c, and scientists are hoping that by checking it out too, they'll be able to figure out the truth. Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be two unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, -375 degrees Fahrenheit. Its core would be made of iron and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baktu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baktu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. Ooh. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baktu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system. The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. Hey, we're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our Sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, And at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered, though. I want to show you something special. So, you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may also have stumbled upon mini Neptunes by now, too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There's also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they're going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary, so it won't blink or turn towards you as you come closer. It's actually a planet. A little bit bizarre, but still very cool. And yup, you guessed it right, we call such eyeball planets. Now, eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turns into a solid object. It starts spinning, and over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. Now, we have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier, if you like craters and stuff. So, one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant, since they're pretty hazy and cloudy. It means it's harder to spot any life there. But some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. I feel cold just looking at this. But the day side is my jam. Plus, it sounds promising when it comes to finding life. With all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large, deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there. And they're probably doing well, having their own world and all that. It's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze, and sea ice could drift into warmer waters. That way, the ocean would cool, and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space, like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warmer waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago. I wasn't around. While the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy icy stuff. I need some hot chocolate.